Okay, we're going to start the periodic trends talking about chemical properties with just a little bit of a review, or at least I hope it is. Okay, so we're going to talk about the similarities and the differences with the elements with some of these reactions. Alkali metals with water, alkali metals with the halogens, and then halogens with halide ions. And then we're going to discuss the differences in the nature from ionic to covalent, basic to acidic, of the oxides across period 3. You are going to be required to know the reactions for water reacting with the oxides of the elements of period 3. Alkali metals, specifically lithium, sodium, potassium, react with water to produce metal hydroxides, hydrogen, and heat. If we were to write that reaction, this is what the reaction would look like with lithium. Lithium, being a metal, is a solid. Water makes the lithium hydroxide, aqueous, which would split up in solution, hydrogen gas, and heat. Simple single replacement. Remember, we can sometimes think of water as an HOH, this hydrogen being the positive, lithium wanting to form a positive ion, going to kick that hydrogen out. Similarly, we will see sodium with water and potassium with water. Let's watch a quick couple of movies.
In this experiment, sodium and potassium react with water. First, bromothymol blue indicator is added to the water. Now sodium is dropped onto the water. It begins to react. As it reacts, the indicator turns blue, showing that the solution is now basic. The sodium melts to form a ball because the reaction is very exothermic. The ball is propelled across the surface by the hydrogen gas evolved. Note the steam which is also produced because of the heat of the reaction. It finally disappears, leaving a solution of sodium hydroxide. Now, potassium is added to the water. It reacts more vigorously. The hydrogen produced ignites immediately, and we see the lilac potassium flame. The bromothymol blue indicator again turns blue.
Okay. Okay, so how about the alkali metals with the halogens, chlorine, bromine, iodine? Metal with nonmetal, hopefully you can guess what kind of product this produces. Ionic. Okay. Ionic metal, nonmetal, forming a solid. This was not done in water because of the lithium being reactive with water, right? Energy is needed to start the reaction. Then we have sodium reacting with chlorine and heat. Why would this be more reactive, more vigorous, and give off more heat? Well, the only two things different between them are the two metals, correct? How do metals react? Well, they react by giving away electrons. Sodium has a larger atomic radius. The electron is farther away from the nucleus, less electrostatic attractive force, gives it away easier, more reactive. And then potassium, very vigorous. Okay. So as you go down the metals in a group, because of the ease in which that electron will be taken off, they are more reactive. We have halogens with the halide ions. They are called displacement reactions. They are also called single replacement reactions. And if you remember from 10th grade, you need the activity series in order to tell, although with the halogens, it is a little bit more straightforward. So I can have potassium bromide in solution, be the bromide ion reacting with chlorine, single replacement. Chlorine ends up being the ion, bromine being the in aqueous solution. This would be red color because of the appearance of that bromine element. Okay, the more reactive halogen displaces the ions of the less reactive halogen. How do you know which is more reactive? Again, think about the periodic trends as we go down a group for a halogen. What makes a halogen stable? It attracts an electron to fill out that octet. So the more electronegative halogen is going to be the more reactive. And consulting an activity series, you will see that that is true. So bromine and iodine, this will not react. Iodine is below bromine in the periodic table. Bromine would have the higher electronegativity. It already has the electron. Iodine is not going to have that electrostatic attraction to pull that electron off. Same thing with the fluoride ion and bromine, but if I have the fluoride element with the bromide ion, the electronegativity of this fluorine will grab that electron. It will become the more stable ion, and bromine would be in solution. That ends this screencast.